Okay, so we're gonna do a quick lesson on economics. This is like the second chapter of my economics class. Okay, so we're gonna do some reviewing of like marginal rate of substitution stuff like that, just because it's on the notes. So first of all, we have kind of sucks that there's no like pointer thingy. Yeah, you can't see this. Okay, whatever. So I'll just use a highlighter, I guess. That works. Okay, so first we have the why is this so thin? Okay, I hope that's good. Okay, so first we have the consumption labor curve. So in this curve, it's always like consumption at the top, and then leisure at it's a leisure, not labor. Leisure at the bottom. So basically, it's like a consumer, like a person can either choose to consume, so like buy goods, or they can choose to like stay home and like relax or like take leisure. And so first of all, here's the indifference curve. We already know what the indifference curve is. Blah blah. Everybody's indifferent between each of these thingies. And so first of all, the slope of the indifference curve is how much of C you would exchange for one more L. So how much C I would give up for one more L. And this is like the change in C over the change in L. Now, the weird thing is that if you want to write it in terms of like marginal utility, which is what, we'll have to use, it's actually leisure on top and then consumption at the bottom. And so you'd have to do like the marginal utility of leisure divided by the marginal utility of consumption. So it might be confusing and might like, throw you off, whatever. But I guess here's like it's like a little quick way to like think about it, I guess. So on this part right here, in this part of the curve, the slope is very flat. Okay, so like the slope, for example, let's say it's like 0.1, whereas the slope at the top over here is like 0.9, so it's like negative 0.9, so it's like very steep. So we'll look at this 0.1 location first. So first of all, if the slope is 0.1, that means that I would give up very less consumption for one more leisure, like because the slope is like very small, so like the consumption is smaller, like way smaller than the leisure. And if the consumption is way smaller than the leisure, like that means that for one more leisure, to get one more leisure, I would only be willing to give up like, I don't know, 1/10 of consumption. Okay, whatever. Think of it like this way. To get like 10 hours of leisure, I would be willing to give up like $1 of consumption. Which means that at this point, consumption is worth so much to me because like literally I would give up so much leisure for just one more consumption. Okay? Which means so first of all, consumption is worth a lot, and the change in consumption is smaller than change in leisure. And if consumption is worth a lot, that means that the marginal utility of consumption is big, and the marginal utility of leisure is small, because like worth a lot, so like marginal utility of consumption is big, blah blah. So if we want this marginal utility of something, we don't know if it's going to be like leisure or consumption, because like we don't really know which the order is. So if we want like the marginal utility of something divided by the marginal utility of another thing to be a small number, since the slope is small and the marginal rate of substitution is a slope, like this is going to be the slope of our thingy, and we want this number to be small. In order to get that, we would have to put marginal utility at the top and marginal utility with respect to consumption at the bottom, since it's going to be like a small number over a big number, which gives you a small number, okay? So it just sort of shows you that the marginal rate of substitution, which is the slope of this indifference curve, is a marginal utility of leisure divided by marginal utility of consumption. Great. So this is our final thing. Next is we're going to look at the budget constraints. So first of all, H is a total amount of hours that the person could work. I don't know why it's H, but like it's just going to be H. Maybe for like hours, I guess. Anyway, so the total amount of hours that I have in a day, it's made up of the time that I stay at home and don't do anything and like take leisure, and plus the time that I work. Okay, so that's the total amount of time. And some other things to note is like W is like the wage, this pi is dividends, like firm profits, and T is like a lump sum tax that I have to pay to the government. So the income that I get is the wage times the hours that I work plus the dividends that I get from like whatever firms minus the taxes. And if I were to rearrange this equation over here to put it as H minus L equals NS, then we can sub that over here and we have that wage times H minus L plus pi minus T is equal to income. So basically this is how much I can consume. So this means that C, so like our total consumption, is equal to this thing. Okay, and this is assuming that I only live like for one day, I guess, so I don't really think of saving any money, so it's just all the money that I earn goes straight to just consuming stuff. Great. Another thing to note is that the wage, this, and then the pi and the t, these are all given. The only thing that we don't know is consumption is leisure, which means that when we plot this budget constraint out, it's going to be like leisure at the bottom, consumption at the top, and WH plus pi minus t. These are all, WH, pi, and t are all given so that we know these. So these make up the y-intercept, and the slope is just this W in front of the L. So it's negative W slope. Great. And another thing to note is that this is like our basic graph which you learn in like first year or whatever, but now that we have pi minus t, we basically just add like a little kink to it just to show that at this point, like this value is what pi minus t is. So for example, if my pi minus t, like if the money that I got just from like firm profits and after paying my taxes is actually like big enough, I wouldn't even go to work. I could just like if I was fine over here, I could just live off of this because I could spend all my time leisuring and get so much money, pi minus t. Now, if pi minus t isn't really enough for my consumption, then yeah, in that case, I'd have to work and think about wage and everything, but whatever. So that's some stuff. So now we're gonna go over optimization. So basically just what's the best option for me. So first, something to note is that I will be trying to maximize my utility. So my utility is like a function of C and L. So it could be, oh crap, holiday. So it could be something like utility, so it could be something like utility CL equals 3C plus 4L. It's not usually like this. It's like the actual functions are usually kind of different, but whatever. Something like that. And with respect to, so taking into consideration that I have a constraint, which is a budget constraint. I can't, spend more than how much I earn, right? Because it's not like I can borrow money or anything like that. So we have this. This is our budget constraint. And this is our utility thingy. So when we want to solve this, we would use the Lagrangian, where we do oh crap. We do the Lagrangian equals UCL minus lambda and the budget constraint. So WH plus pi, blah, 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 and minus blah, blah, whatever. Great. So now let's look at some changes to the budget constraint. So just some things to note is that if there is an increase in the pi, which is also sort of the same thing as a decrease in the t, then the only thing that would be affected is this y-intercept, so it would just shift up. The entire curve would just shift up, not to the side or anything like that, just up. Let's see. If there was an increase in wage, then the thing would rotate a bit because the wage over here, right? So the thing is, it would rotate and it would also meet at a higher point because the wage here is higher, so it would meet at a higher point. Plus the slope would be bigger since the slope is a wage. So it would just, sort of there's a substitution effect, income effect, a little breakdown, whatever. Not too big of a deal. But yeah, there's that. And then over here, so we have labor supply. So labor supply is just that the labor, the amount of hours that's worked is equal to the total amount minus the leisure time. And basically it's that these things are all a function of the wage, because depending on how much the wages, I would choose a different leisure time. And in this case, we're assuming that the substitution effect exceeds the income effect, which means that if the wage is higher, then I'm gonna be oh damn, I can get a lot more money by working, and it's just worth more to me. I don't want to be spending my time, leisuring when I can get so much money working. Which means that this thingy shows that if the wage increases, I would work more. So that's just a thing here, wage thingy, blah blah. I know it's wage at the top and thing at the bottom where it should be as wage increases and increases, but it's just the price is always the y line. Anyway, And this is just the total like workers, blah blah. Okay, so now we're looking at production. So this is like in from like the firm perspective. So that thing before was like for an individual, for like you and me, whereas this is for like a firm. So for a firm, their production, their total production, and this production is like in terms of dollars, like this Y is in terms of dollars. Sometimes I'm not really sure whether it's in terms of dollars or like the number of units that I produce, but like we're gonna assume it's dollars right now because that's how it'll make sense in like a different formula. So yeah, this thing is equal to the total factor productivity multiplied by a function of the K, which is capital, and N. N is a word for labor. I don't know why it's N, but like anyway, that's the thing. Basically this function could be something like, I don't know, K 1/2 N 1/3. I don't know, something weird stuff. Whatever. So anyway, this is a production function, some kind of like form like this. So there are like 5 properties of production function, and we just have to like sort of whenever you're like given like a production function, sometimes questions could be like prove this is a production function or something like that. You just have to show that these 5 properties exist. So first one is constant rate of substitution, which means that not again. Which means that when I increase k and n by like lambda amount, by like if I were to increase k and n, like if I were to multiply k by 3 and multiply the number of n by 3 too, that means that my total y has to be multiplied by 3. So it's like as I increase my, my factors, my output also increases by the same amount. And you just have to like use like math, whatever, like little algebra for that, not big deal. Next is that MPK and MPN are both greater than 0, so like basically marginal product of K and marginal product of N is greater than 0, which means that which means that adding another worker always gets you a higher like Y or whatever, which means that when I add another worker, it's not going to be like, oh, adding this worker made like our entire production actually fall. That would be weird. It's going to increase. It might not increase by the same amount. It might actually increase by like way less, which is what this 3 and 4 is, which is what 3 and 4 is for. But it'll always be greater than 0. So by adding another person, you'll always be producing more. But this also has like a sort of like a constraint where like as you keep increasing the capital or like the labor in this case, the marginal product of capital would decrease. So like if I were to keep adding more and more and more and more and more machines, each additional machine isn't gonna make like so much more of like production for me. Same thing with labor, because like maybe there's too many people and they're all like starting to talk and they're all just like becoming very unproductive. So yeah, so just like a little graph to show it, I guess, is like a graph to show a graph to show like basically 2, 3, and 4, points 2, 3, and 4 is just if you were to have this, it would be like a different graph for like k and different graph for n. I just put them on the same because like the basic same thing. But anyway, so it's like k and then y, and first of all, the slope of this curve here, the slope of the curve is a marginal product of k, is always greater than 0. Like look, it's upwards, it's upwards, it's upwards, but the thing is it's slowing down. Like the slope was like slope over here is like maybe like 0.9ish, slope over here is like 0.01ish kind of thing, whatever. It's like really small. But yeah, that's the deal. Another thing, the final thing is that the marginal product of labor increases as k increases, which basically means as I add more machines, like the amount of stuff that my workers can produce is probably more because there are more machines that they can work with. So like a little graph for that is, so first we have labor and then we have output. So first I have like a little normal MPN curve. So here the slope is MPN, and if k increases, then my MPN is just sort of like as a whole increases. So it just like goes up, just like shifts up. And with this MPN curve over here, it would, if I were to plot N over here and MPN over here, and we know that MPN is always falling as N increases. But basically, with this doesn't mean this is K1. Like with K1, it's over here, but then with the new K2, the entire MPN curve just sort of like increases. sort of similar here, but like, you know, this is like a Y curve, this is an NP curve itself. Okay, let's see. With an increase in Z, so Z is sort of like little, the multiplier at the beginning, so it just sort of like doesn't make it shift up and that, it just sort of like drags up kind of ish. And MPN, and to show the MPN curve, it's sort of like, so we have N at the bottom, MPN over here, and it sort of like shifts the Z curve up just to show that you can like, you know, like at each point at N, you are producing more MPN, you have more MPN. Another word for the Z is a solo residual, which I don't really know what it means. Some kind of like actual value thing, like whatever. So profit maximization, this is optimization, but like for firms, like with the Lagrangian, but like with the consumers. This is for firms. So keeping in mind that the case of the capital is fixed, the profit equals revenue minus expenses, which is equal to the production, so the Z times FKN, minus the wage that I pay to my workers times the number of hours that they work. So this is the profit. This is why I said that we're gonna assume that the Y is gonna be in dollars, because this is in dollars. Like, you know, like for this to be in dollars and for this to be dollars, this has to be dollars, like that. So if I want to max this, I just, with respect to N, I get the derivative of this with respect to N, and the derivative of this utility function with respect to N is MPN, and this is wage, so it says MPN minus wage equals 0, so MPN equals wage, which means that for profit maximization for a firm, you want to be at a point where the marginal product of labor is equal to wage. So if this is our first wage curve, and this is our, you know, our this is our indifference, I mean production curve, yikes, production curve, then I can move the wage curve a bit, like this revenue, whatever, I mean this expense curve a bit up so that it matches up, and this is exactly the point where we want to be. So one thing that you might notice is that with the consumer thingy, when you wanted to show like, oh, like when to put it, whatever, never mind, you know, whatever, with the consumers, whenever like showing stuff like, oh, where should I put the thing, it's always like, this is a budget constraint, this is indifference curve 1, this is indifference curve 2, this is indifference curve 3. So like we're always changing the indifference curve. The budget constraint is always the same. Whereas here for the firm, the production curve is the same. What we're changing though is the actual like their expense. So sort of like their budget-ish kind of curve, which might be a bit odd, but the deal is that for consumers, our goal, like with the Lagrangian and stuff like that, is to maximize utility considering we have a budget constraint. So like basically like we're changing utility considering that we have a budget constraint, whereas with the firm stuff, the way to think about it is like, even though it's like you can think about it the other way, the way to think about this is like we're trying to minimize cost, keeping in considering the production. So here it's sort of like production is fixed, and then like we're just trying to like figure out how to minimize the cost. And so that's how we do that. And so, so this is it. And like, so there's like a thing with like the Lagrangian where it's always, do I have the thing here? I didn't, okay. Over here, it would actually be, it would be like the cost function. So like Wn minus Lagrangian, I mean the lambda, and then production function. Whereas, you know, remember with the consumers, it was like utility CL minus Lagrangian and then budget constraint. So it's just like a little bit of different, like it's just like a different way of thinking about it. Oh, I guess almost 19 minutes. Labor demand, this is basically just, you know, as the wage increases, I am going to hire less people because as a firm, I don't want to be spending that much money. And then in terms of garments, just in the one period model, which means that there's like no like, you know, free or whatever, is just garment equals taxes. So like the garment spends all the money that they take in taxes. There's nothing there. Okay, bye.